Now inside this lecture, let's try to talk about another object that is available inside the OpenAPI specification, which is external docs. So there might be some scenarios, though you have mentioned many details inside your OpenAPI specification and it might be sufficient for most of the consumers, but few consumers, they'll ask more details about your business, products, APIs, which you cannot describe all of them inside your OpenAPI specification. So for this kind of consumers, what you can do is you can define an object with the name external docs, and inside this external docs object we can provide an URL where any consumer can navigate and read some additional details about your APIs or products or about your company. And inside this external docs, two fields are allowed. The very first one is description, and this is an optional field, and the second one, which is an URL, where you can provide the external resource URL details, and this URL is a mandatory field. So if you observe the OpenAPI structure, external docs we can define inside the root level. Like inside external docs we can define the description and URL is a mandatory field. And just like how we are defining these external docs at the root location, we can also defining these external docs inside our paths also. Like if you go to the paths and open this path object, and if you click on any of the object of HTTP method, you can see there is an external docs object that we can define here with the same fields like description and URL. And according to me, I think whatever external docs information that we are going to provide inside the OpenAPI root level, that should be fine. And I see people rarely uses external docs inside the API operation objects as well. So now what we can do is we can define this external docs information inside our OpenAPI documentation at the root level. So for the same, I'm going to my Swagger editor. So here you can see just after the info object, I'm going to create a new object which is external docs. And once I define this external docs, I just need to press enter and provide tab space, and post that I'm going to introduce two new fields, which is description and URL. So the description is external documentation and this is some sample URL. So if you try to see how this is going to look like inside Swagger UI, so you can see there will be a hyperlink with the display value with whatever content that you have provided inside the description field. So that's why please make sure you are providing some meaningful description under this description field, so that my consumers, they can easily understand and try to correlate that this link will take them to the external documentation. So I hope you are clear about how to define the external docs information. So very similarly, you can also define inside your API path operations as well. So with this, we have discussed a lot of new concepts inside this section. So before closing this section, what I'm going to do is I'm going to take this version of OpenAPI specification document and upload the same inside our GitHub location. So feel free to refer the same whenever you want to brush up these concepts like external doc, OpenAPI extensions, operation ID, deprecated. So all these concepts we have discussed inside this section, and I hope you are very clear with them. So with this, we can close this section. Thank you, and I'll catch you in the next section. Bye. Now inside this section, let's focus on how to describe security of our APIs inside OpenAPI specification. Like you can see here, we have a root object which is security to describe the security requirements of our APIs. Like inside real projects where we develop some APIs and we'll provide them to our consumers to consume these APIs for our day-to-day business use cases. But we never expose our APIs without any security, like not any consumer can come and they can consume my APIs. It won't be so simple and straightforward. We always enforce some security restrictions on our APIs, which means anyone who want to interact or consume my APIs, they need to understand the security requirements of my API, whether I'm using basic authentication or OAuth2 or OpenID or bearer authentication. So once they identify my security requirements, accordingly, they need to send those details inside the request so that the request will go through to my backend server. We can't imagine APIs in the real projects without security. That's why inside this section, we are going to focus a lot around security, how to describe our API security requirements inside the OpenAPI specification. For the same, let me take you to the quick introduction slide around security. So like you can see here, OpenAPI supports multiple security standards. Like with the help of OpenAPI specifications, you can define HTTP authentication schemas like basic authentication, bearer authentication, or using API keys for your security, or OR2 or OpenID Connect. So all these are security standard frameworks or approaches which everyone uses inside their projects. So you take any scenario like where two different APIs or two different applications or two different microservices they want to consume with each other. So using one of these approaches, the developers, they try to secure their APIs. Otherwise, if they don't have any security for their APIs, it's going to be a nightmare for them because everyone is going to consume their services and there can be data breaches or security issues. So inside OpenAPI specification, whenever we want to describe the security requirements of our APIs, we just need to make sure we are defining two objects. The very first one is security schemas. So inside components, just like how we define the schemas, responses, request bodies, parameters, so very similarly, we can also define security schemas. So under these security schemas, we can define any of the security protocols or security standards from the above list. Like we have HTTP basic authentication, bearer authentication, OR2, OpenID, API keys. So from these 5 security authentication mechanisms, we can take one of them or we can take combination of them and describe them inside our security schemas under the components object. So once we define those objects, definitely in order to enforce those security details to our APIs, we can use the security keyword. So using security keyword, we can refer the security schemas that we have defined under the components. So this way, with the help of security schemas and security, we are going to describe the security requirements of our APIs. So this is just an introduction I want to provide. If something is not clear, don't worry. When we implement this inside our OpenAPI specification document, then it will be super clear for you. But for now, please note that we need to use the security schemas and security keywords to describe the security of our APIs inside our OpenAPI specification. So with this, I'm assuming you are clear about what is the agenda for this section. So let's continue the journey of security in the next lecture. Thank you, and I'll catch you in the next lecture. Bye. Now inside this lecture, let's assume we want to use basic authentication and bearer authentication for our APIs, and the same we want to describe or explain inside our OpenAPI specification so that my consumers are clear about these security requirements and they'll make sure they are passing these security details whenever they're making a request. So like you can see here, the very first or the simplest security approach that anyone can follow is HTTP basic authentication. So inside this authentication, what will happen is my consumers, whoever is trying to consume a API, they will send a header inside the request. The header name has to be authorization, and inside this header, the value that they are going to send is basic followed by a space, and after the space they need to mention the base64 encoded value of username : password. Suppose if the username is EasyBytes and the password is admin123, the way the consumer send this information is the value has to start with basic, indicating that they are following basic authentication. And once we define this basic inside the authorization header value, we need to provide a space, and after the space, the base64 encoded value of EasyBytes : admin123 will be sent as part of the request. So this is about basic authentication and how it is going to work. But the next question that we have here is how I can define or how I can describe this HTTP basic authentication inside my OpenAPI specification. For the same, like I was telling before, first under the components, we need to define the security schemas. Like you can see on the left hand side, I have defined security schemas under the components, and under the security schemas, we can define any number of security schema details. And that's why we need to provide a unique name for your security schema that you are going to describe. The name that I have chosen here is basic auth, and this name can be any arbitrary name. You can choose any name. Under this basic auth security schema, whenever we want to use HTTP basic authentication, we need to provide the type as HTTP and the scheme is basic. So once we define these security schemas under the components, as a next step, what we have to do is we can define the root object, which is security, and inside that we need to mention the basic auth, which is the name of our security schema for HTTP basic authentication, as one of the array element. The same you can see in the example that I'm showing on the left hand side. But the important note that you need to make sure here is, for all the security schemas, whenever we are trying to refer from the security object, we need to provide the square brackets. So for HTTP basic authentication and for any other simpler authentication or security mechanism, this is going to be empty. The reason is, inside these brackets, we usually mention what are the scopes that are supported by this particular security mechanism. But these scopes are available only inside the advanced security frameworks like OAuth2 and OpenID. So that's why for simple authentication mechanisms like basic authentication, this is going to be empty. And using the root security object, we can mention the security schema, and whenever we does that, the security will be applicable for all your APIs inside your OpenAPI specification. But if you don't want that, and if you want to define only at operation level, you can define this security keyword inside your operation object as well. So the same you can see on the right hand side example. So under the path example, which is supporting HTTP GET, I have defined my security keyword along with the security scheme, which is basic auth. So this way we have a flexibility to enforce the security at the API specification level or at the API operation level. So after the basic authentication, we have bearer authentication, which is supported by the OpenAPI specification. So everything is similar like whatever we have discussed for the HTTP basic authentication. The only difference between HTTP basic authentication and bearer authentication is, inside the bearer authentication, my consumers will not send the username and password. Instead, they will send token like JWT token, which is cryptic in nature. And to indicate that they are sending a token but not the actual username and password, they need to pass the bearer as the starting value inside the authorization header value. So that's the only difference between basic authentication and bearer authentication. We usually pass the username and password only during the very first request that we are going to send. And once we send those details, definitely my backend server can provide a JWT token, and the same JWT token I can use for multiple requests with the help of bearer authentication token. So this also protects us from exposing our username and password unnecessarily for every call inside the HTTPS network. So coming to the how to describe this inside the OpenAPI specification, this is very similar. The only difference is the scheme that you are going to mention under the security schemas, it is going to be bearer. And whenever you are using bearer scheme, you need to mention what is the format of your token, what is the bearer format. So to define that, we need to use the keyword bearer format, and we need to mention one of the valid value for bearer format, which is like JWT. And the security scheme of bearer authentication can be referred in the same way like we have done for HTTP basic authentication. Even for bearer authentication also, the scopes will be empty. That's why you can see the square brackets does not have any values inside them. So I hope this is all clear to you, like what is HTTP basic authentication and what is bearer authentication and how to describe this inside the OpenAPI specification. So in the next lecture, what we can do is we can try to implement these inside our OpenAPI specification so that you have complete details and you are super clear. Thank you, and I'll catch you in the next lecture. Bye. Now inside our OpenAPI specification, let's try to define the security requirements for our APIs. So for the same, first I need to define the security schemas under my components object. For the same, let me go to the end of this file. So here what I'm going to do is just in the same position where we have defined the responses, links, schemas, parameters. So in the same position, I'm going to define new object under components. The new object name is security schemes. So once I define the security schemes, under this, I'm going to mention two security scheme details. Like you can see, the very first one is basic auth, and this name can be arbitrary name. So this has to be a unique name inside your security schemes. The same name you can refer inside the security keyword of OpenAPI specification. So similarly, I have one more security scheme with the name bearer authentication. For both of them, the type is HTTP. And coming to the scheme, for the HTTP basic, it has to be basic, and for bearer, it has to be bearer. And since inside bearer, we are going to use the tokens, we need to tell what is the format of the token that you are going to use with the help of bearer format. And since JWT is a mostly used token format, I have mentioned this as an example. So whenever you are using any other bearer tokens, feel free to mention the same, but here we have just mentioned the most commonly used, which is JWT, and JWT means JSON Web Token. So that's a full description of JWT. And now we have defined these details under the security schemes. As a next step, what we have to do is we have to refer them inside the security keyword as an array element. So for the same, let me go to the starting of this file. So here what I'm going to do is I'm going to mention the security requirements just above the path object. So here we just have to type the security, and inside this, since it is going to accept the list of array elements, we need to provide hyphen. And after the hyphen, you just have to refer the security scheme that you have introduced under the components. So once you mention the security scheme name, you just have to give colon, and after that you need to provide the empty square brackets. So this is because basic authentication and bearer authentication, they both does not support the scopes inside the security. So that's why we need to mention an empty value. So let's do the same for bearer auth as well. So here you can see I have mentioned two types of security requirements for our APIs. One is basic auth and the second one is bearer authentication. So since I have defined these details at the root level under the security keyword, so this security will be applicable for all the APIs inside my OpenAPI specification. So if you go and observe right now the Swagger UI, so you can see here there is an authorize button against our server URL, and every API right now has this security lock icon, which indicate that these are protected APIs, and anyone want to consume these APIs, they need to pass the security details. So like you can see here, all the APIs right now, it is showing as secured APIs. So now think like my consumers, they came here and they looked at the documentation and they understand these are the secured APIs, but how they are going to understand what is the security mechanism that we are using is they can click on this lock button either on the server or against these APIs. So let me click on this icon here. So here you can see it is showing I am supporting two types of authorizations. First one is basic auth, which uses username and password. And the second one is bearer authentication, where we need to directly provide the JWT token. For example, if I want to understand how this basic authentication I need to pass inside my request, what they can do is they can give some username and the password also they can provide. Now if I click on this authorize, you will see these details will get saved. And now if I can close this and open any of these APIs and click on this try it out option and click on this execute button, you should be able to see inside my curl request there is an header with the name authorization and with the keyword basic followed by the base 64 encoded value of my username, colon and password. So this way they can also use this try it out option along with the security details. So that's why as of now you can see all my security icons are showing as a closed lock icon, which means there are some authentication details provided by the consumer inside the Swagger UI. But if I try to clear them by clicking on this logout and close this, now you can see all my security icons, they have this open lock, which indicates there are no security details present inside the request header. So this way we have described two types of security requirements for our APIs. The very first one is basic auth and the second one is bearer auth. And of course, using both of them is not mandatory. You can use only one of them or you can use combination of them. It's up to you. But whatever you are accepting inside your backend server, you need to define all those details inside your OpenAPI specification. So I hope this is all clear to you. Thank you, and I'll catch you in the next lecture. Bye. Now inside this lecture, let's try to explore the other security mechanism that we can explain inside the OpenAPI specification. And this mechanism is API keys. So inside this API key security mechanism, how this is going to work is my clients or consumers are going to provide an API key which is like a token. And this API key they can provide inside the query parameters or in the request header or inside the cookie. So describing this inside our OpenAPI specification is very similar to what we have done for HTTP basic authentication and bearer authentication. The only change is under the type you need to mention the value as API key instead of HTTP. And since we can send this API key in multiple places, you need to mention where you are going to send. Is it inside your header or inside your query params or inside your cookie? So that's why using the in field, we need to describe where we are going to accept that API key. For example, if you are going to accept the API key inside the header, you need to mention the value as header against to this in field. And after the in field, we can define the name of the header. If you are sending the API key inside a header, the name will act as a header name. Otherwise, it will be cookie name or query param name based upon what value you are mentioning inside the in field. So under the name field, we need to define the name of your header or cookie or your query param. So here the name that we have chosen is x-API-key. And remaining everything is very similar. Like we can refer this security scheme inside our security with the help of hyphen and what is the security scheme name followed by empty square brackets, because even API keys also does not support the scope. So scopes are only for the OAuth 2 and OpenID frameworks. So this is how we can describe API key security inside our OpenAPI specification. So now let's quickly document this inside our OpenAPI specification. For the same, let me go to the Swagger editor. So here inside my security schemes, I'm going to introduce a new security scheme. Like you can see here, the name that I have chosen is API key auth, and again this name can be anything. And for API key, the type we need to mention is API key. And please make sure this K is in capital letters inside the API key. And after the type, you need to mention the in as an header or query or cookie. And once we define this in field details, we can provide the name of your header with the name attribute. And the name that we have chosen is x-API-key. So now what I can do is I can take this security scheme name and I can go to the top of this page. Under the security, I can define one more array element with the help of hyphen and mention the API key, which is the security scheme name that I have defined under the components and followed by the empty square brackets. So now if I click on this, any security icon, you can see, so there are three types of security mechanisms supported by my APIs. The very first one is basic auth, and the second one is bearer authentication, and the third one is API key auth. So like you can see, if I try to provide some header value here and click on this authorize, and post that I'm going to try out one of the API with the try it out option. And if I click on this execute, if you go to the curl command, you can see there is an header inside my request with the same name that I have defined inside my OpenAPI specification. And this is the value that I'm trying to send. So this way my consumers also through their client code, whether it can be in Python or Java or JavaScript, they need to send the same header with the same name and the value they need to pass the API key, which they might have received from the producer or provider. So with this, I'm assuming you are clear about how to describe API key security mechanism inside the OpenAPI specification. Thank you, and I'll catch you in the next lecture. Bye. Now inside this lecture, let's try to understand how to describe OAuth 2 and OpenID Connect inside our OpenAPI specifications. Like I was telling before, OAuth2 and OpenID Connect are more mature and advanced frameworks, and majority of the enterprise organizations, they use these frameworks for their authentication and authorization inside their web applications. If you are not aware about how this OAuth2 and OpenID Connect frameworks works, then don't worry, please just focus on how to describe these security frameworks details inside the OpenAPI specification. But I can provide a quick introduction to OAuth2 and OpenID Connect very quickly here. So usually using OAuth2 and OpenID Connect frameworks, we can give API clients a limited access to the user data on a web server. Suppose think like there is a web application which can analyze your tweets or your Facebook post or your LinkedIn post, and it can provide some insights like how many posts you are making, how many tweets you are making per day or per month. So in order to do this analysis, so this third-party web application, it needs to understand your data by logging into your Twitter account, Facebook account or LinkedIn account. But it will be a foolish to give your credentials to this web application to go ahead and analyze by logging with your own credentials. Instead, what this OAuth2 framework recommends is you can go to the third-party web application, and from the third-party web application, you can give a consent saying that this third-party web application, it can use my Twitter information. So for the same, whenever you give this consent, your third-party web application, it will land you to the login page of Twitter account. So here you as an end user or the resource owner, you have to enter your own credentials, and once you enter the credentials into the Twitter login page, it will provide an access token to the third party web application. So nowhere here you are providing the credentials to the third party web application. Instead, this third party web application will redirect you to the Twitter login page or LinkedIn login page or Facebook login page, where you can enter your own credentials, and once your credentials are valid, you need to provide a consent to the LinkedIn or Facebook or Twitter saying that so and so third party application is trying to access my data and I am allowing it. These are my credentials. If the credentials are correct, please give the access token to the third party web application. And once my third party web application get this access token, it can send that access token to the Twitter or LinkedIn or Facebook to get my data. And if the access token is valid, my Twitter backend server or resource server, they are going to provide the information that this third party web application requested. And in the same scenario, there is a concept called scopes. Like instead of you sharing all kind of data, like every information inside the Twitter or Facebook or LinkedIn, you can define scopes like, do you want to share only profile details? Do you want to share only your post details? Or do you want to share your only address details? Or do you want to share only your contact details? So like that, you can define the scopes, and whatever scopes we are allowing, the same details will be shared to the third party web application, but not the other details. And similarly, we can also have scopes like read only, write only. So whenever we have a scope of type read only, that means my third party web application or client application, they can only read my data, but not they can update or delete or create new data. So that's the purpose of scopes inside the OAuth2 and OpenID. And of course, you may have a question like, what's the difference between OAuth2 and OpenID? So there is only one difference. OpenID Connect is built on top of OAuth2 framework itself. Like inside OAuth2 framework, we only get access token, whereas in OpenID framework, along with the access token, it also give ID token. So using this ID token, my client applications, they can know the user details, like what is the email of the logged in user, what is the username, what is the contact details. So those kind of identity details or user details will be embedded inside an ID token, which is in the format of JWT inside the OpenID Connect. Whereas in OAuth2 framework, we'll only get an access token, but not the ID token. That's the only difference between these two frameworks. And these days, everyone is using OpenID Connect because it is giving everything that OAuth2 framework is giving. And on top of that, it also provides an extra token, which is ID token along with the access token. So this is a quick introduction about OAuth2 framework and OpenID Connect. And if you didn't get anything, don't worry. My intention is only to provide some quick introduction. But since these are advanced topics, I would request you to take a course on OAuth2 and OpenID Connect if you are interested. But let's come into the discussion of how to describe these frameworks or security requirements inside the OpenAPI specification. So like you can see here, whenever you want to describe OAuth2 framework inside your OpenAPI specification, you need to use the type as OAuth2, and inside the OAuth2 framework there are multiple flows that are supported based upon the scenario you are into. The flows are like you can see on the right hand side, authorization code, implicit, password, client credentials. So these are all the flows that my OAuth2 framework supports, and we can use these flows based upon the scenario that we are into. Suppose if two systems are trying to communicate with each other where there is no end user is involved, we can use the client credentials flow. But if you have a scenario where as an end user is involved, then you can use the authorization code grant flow. So similarly, we have other flows as well that supports various scenarios that we have inside the web application. So that's why we need to mention these flows inside the security schemes. Under the flows, we need to mention what is the flow name that we are trying to describe. The flow name that you can see on the left hand side that we are using is authorization code. Under the authorization code flow, we have to provide details like what is the authorization URL, what is the token URL, what are the scopes that your OAuth2 framework supports. So once we define these details, under the security keyword, we can refer the same security scheme that we have defined under the components, but this time instead of giving an empty square bracket, we need to provide all the scopes that your OAuth2 framework is going to support. And very similarly, inside OpenID Connect, whenever you are using this framework under security schemas, you need to mention the type as OpenID Connect, and whenever we are using OpenID Connect, we need to pass the what is the OpenID Connect URL that my consumers can connect in order to get an ID token or access token. And once we define these details under the security schemes, we can refer the same under the security keyword by referring to the security scheme that we have defined. And just like inside OAuth2 how we are passing scopes, here also we can pass the scopes instead of mentioning the empty square brackets. So I hope you are clear how to describe OAuth2 and OpenID Connect security requirements inside the OpenAPI specification. In the next lecture, let's try to describe one of the security requirements inside our OpenAPI specification document. Thank you, and I'll catch you in the next lecture. Bye. Now inside this lecture, let's try to describe OAuth2 security requirements inside our OpenAPI specification. For the same, I just have to go to the end of this document. And inside the security schemes, I'm going to create a new scheme details. Like you can see, the name that I have given here is OAuth2 auth code, and this name can be anything. Under type, since I want to use OAuth2, I have to give this OAuth2 value. If you are using OpenID Connect, you can provide the same value that we have discussed in the previous lecture. You can also refer inside the slides. Under the flows, since it is going to support multiple flows, we need to mention which particular flow details that you are trying to configure. So here we are trying to configure authorization code. That's why I need to provide this value. And if you have a scenario where you want to describe multiple flows, then that is also possible. You just have to define one more flow inside the same position where your authorization code is started. So now under this authorization code, the values that your consumers expect whenever they are trying to use OAuth2 framework with authorization code flow is what is the authorization URL which I can connect to get an authorization code, and what is your token URL which I can connect to get an access token. So these URLs we need to provide. So don't worry if you are not getting anything around here, because you can only understand these terminologies if you are an expert inside the OAuth2 framework. If you are not, don't worry. Like I said, please simply focus on how to configure these details inside the OpenAPI specification. And after this, we have to define the scopes that are supported by your OAuth2 framework. So here I am trying to define three kinds of scope like read, write, and admin. So whenever I'm getting an access token which has a scope of read, then I can only read the information but cannot update it. And very similarly, if I get an access token which has a scope of write, then I can read and write. And similarly, I also have an admin scope, which means this admin scope will be given to the admin logins only, where an admin user can run or can do some extra functionality inside my web application, which means they'll have some elevated access. So these scopes are completely, you can choose whatever name you want, but here I just choose something very simple like read, write and admin. So once we define these details, like we need to go to the starting of this document under this security, and here we need to give the name of the security scheme that we have defined just now. This is the name. And since OAuth2 framework is going to support the schemes, we should not mention these empty square brackets. Instead, we need to mention all the scopes that your OAuth2 framework supports. So now if you go and check the authorization mechanisms that are supported by your APIs, you can see there is a basic auth, bearer auth, API key, and similarly I have an OAuth2 where it is asking what is your client ID, client secret, what scopes you are trying to get an access token. Like I can give a client ID, client secret, and I can click what are the scopes that I am requesting. For my client ID inside the backend authorization server, if the scope is already configured to read, then only I'll get the valid access token. But if I'm trying to be over smart and if I'm trying to get an admin access token, it will not work, because for this client ID in the backend, it might have configured this client ID is only eligible to get an scope of read. So this is how OAuth2 works internally. So this way we have successfully defined various security mechanisms inside our OpenAPI specification. So I hope this is clear to you. Thank you, and I'll catch you in the next lecture. Bye. As of now, inside our OpenAPI specification document, we have enforced the security on top of all the APIs, because whatever security details that we have defined here, we have defined them at the root level of the OpenAPI specification, and that's why these security requirements are applicable for all your API operations. But we also have an option of defining security requirements separately at operation level. Like in the scenarios where for a particular API, I want only basic authentication, but not the other security mechanisms. What I can simply do is I can simply copy the security along with the basic auth, and I can go to the operation. Maybe for these get categories, I want to enforce only the basic authentication. So then what I can do is inside my operation object somewhere, maybe after operation ID or after description, I can just simply mention this, like this is my security requirement and I want to support only basic auth. So now if you go and check the categories API path by clicking on the security icon, you can see it supports only basic authentication and it does not support other kind of security mechanisms that we have defined at the root level. So this way we can override the security details at the API operation level. Now let's see one more scenario, like if you don't want any security for a particular API. Maybe for this next API that we have, which is category/category ID, you don't want to enforce any security, then we can simply type security and followed by empty square bracket. So if you go and check the second API, you can see for the second API there is no lock icon or security icon. This means this second API does not require any security details. Anyone can access this API without any username, passwords or tokens. So this way we can customize the security requirements at operation level. Maybe like you can completely ignore them or you can play with the combination of your securities. So it's up to you how you want and how your business scenario driving your OpenAPI specification document. So with this, we are done discussing everything about security inside the OpenAPI specification. So what I'm going to do is I'm going to take this version of OpenAPI specification and upload inside the GitHub location. Please refer to the same whenever you have some questions. So I hope everything is clear to you so far. Thank you, and I'll catch you in the next lecture. Bye. As of now, we have defined a complete OpenAPI specification document for an application called EasyShop, and we are almost towards the end of this course. And inside this last section, we are going to discuss some exciting features and out-of-the-box features that we can leverage with the help of OpenAPI specification. So like you can see here, as of now, we have built our OpenAPI specification inside the Swagger editor, and this is my YAML file. I can download this and I can upload into some GitHub location, and everyone is happy with this kind of working environment. But there might be some scenarios where you have your OpenAPI specification and you might end up doing some changes onto this OpenAPI specification on day-to-day basis. And obviously, whenever you change your OpenAPI specification document, we need to send this updated YAML document to your consumers saying that so and so updates are happened. And what my consumers is going to do is they are going to take this YAML file and they are going to put inside a Swagger UI or Swagger editor so that they can visualize your OpenAPI specification document and try to understand the new changes. But this is a very manual process where whenever you make some changes to your OpenAPI specification, you need to send the same to your consumer, and your consumers, based upon the latest YAML file, they are going to explore inside the Swagger UI. So this can be fine if you have only one or two consumers, but if you have multiple consumers, we can't do this coordination manually every time, and it's a very cumbersome process. So instead, what we can do is we can host or deploy our OpenAPI specification as a website so that my consumers, they can always refer to the website to understand my APIs that are exposed by EasyShop or by your organization. And of course, you may raise a point here saying that if we are maintaining this YAML file inside the GitHub location, can't my consumers take the latest YAML file every time from the GitHub repository? Yeah, that's a valid point. But again, there is a manual process. They have to take your latest YAML file, they have to put it inside a Swagger UI, and post that only they can visualize your OpenAPI specification. But instead, what we can do is we can deploy or host our OpenAPI specification as a website so that every consumer, they can always navigate to that website and they can find the latest YAML specification with the help of Swagger UI format. So as a next step, what we can do is we can explore this hosting and deploying of OpenAPI specification in the next lecture. I hope this is clear to you, like what is the problem that we are facing right now and how to overcome this. Thank you, and I'll catch you in the next lecture. Bye. Like we are discussing in the previous lecture, we can host our API documentation so that the consumers, they can always refer to this website to understand our API details that we are trying to describe with the help of OpenAPI specification. And whenever we want to host our OpenAPI specification, we can host our API specification with the help of a GitHub pages or with the help of AWS S3 bucket, GitLab pages, Dropbox, Google Drive. So there are unlimited options. You just need an HTML page and your OpenAPI specification file. And using these two files, you can deploy any of these options, or you can simply deploy inside your web server or application server as well, which you are maintaining inside your organization infrastructure. So there are unlimited options. Please choose whatever works for you. But inside this lecture, I am going to show you how to host our OpenAPI specification with the help of GitHub pages. The reason why I have chosen GitHub pages is because GitHub is a very close tool to the developers community. So that's why I have used these GitHub pages to deploy our OpenAPI specification. But here we have a problem. Like as of now, we just have an YAML file, but whenever we want to deploy into some website, my website can only have HTML files, JavaScript files, CSS files. So using these primary files like HTML, JavaScript, CSS, I can build a website. But as of now, I don't have any of these files. So for the same, let me show you how to overcome this problem. So for the same, let me go to the GitHub repository of the course. So like you can see here, I came to our GitHub repository, which is github.com/easybyte/OpenAPI. Like inside this GitHub repository, we are maintaining all the OpenAPI example files at different milestones that we have achieved inside this course. like right from the initial topic that we have discussed, which is minimal document. And very similarly, you can find all the versions of YAML files based upon each concept that we have discussed. So the last changes that we have done inside our OpenAPI is related to security. So that's why you can see this is the greatest and latest YAML file that we have built inside this course. If you open this, so this is our complete YAML file. And very similarly, inside our OpenAPI repository, I have created a new folder with the name OpenAPI deployment. So if you can open this folder, inside this you can see there is an index.html. So if you open this index.html, you can see I have mentioned some HTML code. So this is not super complex. This is a very simple HTML file. You can see there is some HTML opening and closing tags, and there is an head section. So inside the head section, you can see I am importing CSS files which are developed by Swagger UI team from this CDN location. So if you open this CDN location, which is Content Delivery Network location, this is the entire CSS file that our HTML is going to import whenever we deploy our HTML into a web server. And very similarly, we also have JavaScript code. Like you can check here with the help of script tag, I'm trying to import a JavaScript library which is developed by Swagger UI. So using this URL, I'm trying to refer this entire JavaScript. You can also verify that. So this is complete JavaScript library. So these libraries of JavaScript and CSS, they are already developed and hosted by Swagger UI team. You just have to import inside your index.html. After this, you can see whenever someone is trying to access this index.html using this window.onload function, I'm trying to create this object of Swagger UI bundle, which is available inside this JavaScript library. For this object, I need to provide what is the URL of my OpenAPI YAML document. Since I'm maintaining the YAML document inside the same folder location where my index.html is present with the name openapi.yaml, I can mention the URI as simply openapi.yaml. But if you want, you can also define the URL where your openapi.yaml is present. And this file name can be anything. It's just that inside this YAML file, you should have a valid OpenAPI specification content. And after that, I'm creating a DOM ID with the name egshop-oas. So OAS indicates OpenAPI specification. And after that, I need to provide this configuration, which is deep linking as true. And once we define this bundle on the load of the page, you can see inside my HTML body, I have a div ID with the same name, which I have defined with the help of DOM ID. So the same value you need to provide here. So once we have this HTML and your openapi.yaml, you can take these two files, like you can download from the repository, both HTML and this OpenAPI document. So this OpenAPI document that I'm showing here will have all the changes that we have discussed, but you can put your own content as well inside this openapi.yaml. So as a next step, what we can do is using these two files, we can create a GitHub page. So in order to create a GitHub page, what I have to do is I have to go to my GitHub homepage, and next I will go to the repositories tab that I have, and I'm going to create a new repository. So in order to make your repository to work as an GitHub web page, there are two criteria that you need to make sure you are following. The very first criteria is your repository name should have your username. Like my username of my GitHub login is EasyByte. So that's why I have to use the same username, and post that I have to mention the value github.io. And once we mention this repository name by following the naming convention that I have discussed, we need to make sure the repository is of type public. So this is the secondary requirement to convert your GitHub repository as a public web page with the help of GitHub pages. So the very first one is your repository name should have your username.github.io. And the second condition is you should make your repository as an public. Post that, I can simply click on this create repository. Once the repository is created, as of now, you can see it is an empty. What I'm going to do is I'm going to upload the HTML file and our OpenAPI file using this upload option. So let me click on this choose your files option, and these are the two files that I have. So let me select them and upload, and once I upload, I need to commit these changes into my repository. So once I commit these changes into my repository, you can see under this repository, which is easybytes.github.io, I have uploaded two files. One is HTML file and the second one is OpenAPI YAML file. So now what we can do is we can go and check this actions tab that we have here. Like if you click on this actions, you can see the page is build and deployment is being queued. So let's wait for this to get completed. So as of now, you can see it is in progress. So once this page's build and deployment is completed, you should be able to access this website, which is easybytes.github.io. So now you can see it is showing in green color, which means our page's build and deployment is completed. So let me go and access our web page, which is easybytes.github.io. So here you can see the magic. Inside this website, we are able to see all our APIs that we have described so far. And along with the APIs, you can see these are the schemas that we have described. And my consumers, they can also explore all these APIs that we have described. And for some reason, if they want to know the actual YAML file, they can use this download option here. So if they click on this, it will open the YAML file using which this website is built. So here you may have a question like how this magic is happening. Like inside our index.html, since we have imported the CSS and JavaScript libraries of Swagger UI, it is taking the OpenAPI.yaml which we have provided, and from the same, it just prepared an UI, and this is how it is going to look like. And this is very similar to what we have seen inside the Swagger editor. I hope you like this approach, like hosting our OpenAPI specification inside a website with the help of GitHub web pages. And of course, you can simply deploy your HTML and YAML file inside any of the web server or any of the options that you have inside the industry. It's up to you which one you want to follow. But please follow this approach so that your consumers, they can always refer to the latest and the greatest OpenAPI specification document. And in future, whenever you want to make some changes, you can simply make those changes and do a push into this GitHub repository, and automatically my website will get also refreshed. I hope this is clear to you. Thank you, and I'll catch you in the next lecture. Bye. Now inside this lecture, let's try to explore another exciting option that we have whenever we are using OpenAPI specification. So using OpenAPI specification document, we can mark the API so that my consumers, they don't have to wait for the producers to complete their development. Using this OpenAPI specification document, which has some examples data, they can simply mark the APIs and they can continue their development without waiting for the producers to complete their development. So this is one of the great advantage where both consumers and producers, they can start the development parallelly if they have a final copy of OpenAPI specification. So whenever you want to mark APIs using OpenAPI specification, there are multiple options that we have, but inside this lecture, we are going to use one of the open source option that we have, which is with the help of Prism. So Prism is an open source HTTP mock server that can mimic your API's behavior as if you have built these APIs with the help of a Java code or backend code or Python code. So this Prism is going to support the OpenAPI 3 version and Swagger 2 version as well. But since inside this course, since we have used the latest version, which is OpenAPI 3 version, let's use the same to mark the APIs with the help of Prism mock server. So in order to mark our APIs, we need to follow the 3 steps like I was showing on the screen. The very first step is you need to download the Node.js and install inside your system. And I have also given the URL from where you can download this Node.js. So once you install, in the second step, you need to install the Prism related libraries with the command npm space install -global space @stoplight/prism -CLI. So once we install these Prism related CLI libraries inside the step 2, then we can jump into the third step. Inside the third step, you need to run a simple Prism command, which is prism mock, and what is the location of your OpenAPI YAML document. And after that, what is the port where you want to start your mock server to be created. So the same we can mention by using the -p, which indicates port, and after -p you can provide the port number like 8080. So these are the 3 steps that you need to follow. You can simply execute all these 3 steps within a matter of minutes, and post that your mock APIs are ready with the help of your OpenAPI specification. So I hope you are clear like what are the steps that we need to follow. So let's quickly jump into this and try to mock our APIs by following these steps so that you are clear when I do all these steps in live. So for the same, first let me go to the Node.js website. So this is the Node.js website. You can click on this downloads option, and based upon the operating system that you are using, you can download either Mac version or Windows version, or you can also download the Linux version as well using the options that you have. So once you download and install that, you can go to your command prompt inside Windows or terminal inside Mac OS system, and you can verify if the node installation is successful or not with the help of a command which is node-version. Since I'm using Mac OS, I have opened my terminal, and the command that I want to run is node-version. So we need to give this hyphen 2 times. So once you run this command, you can see the version of the Node.js installed inside your laptop or inside your local system. So the version right now I have is 18 version. So this confirms that Node.js installation is successful. And once you are done with the step 1, then as part of step 2, you need to run the command that we have discussed. The command is npm install -global, and post that we need to provide this value which is @stoplight /prism-cli. So let me execute this command. Like you can see here, the installation started, and please wait for a couple of minutes. So this will install all the Prism related libraries inside your local system so that we can use the Prism related commands. Seems I have an access related issue, so let me clean the console once. So now what I can do is I can just mention sudo before this command. Since I'm using the Mac OS, I don't think for Windows users you need to provide this sudo command, but please make sure you're starting your command prompt as an admin. So here, after giving this sudo value in front of my command, I can execute this, and this is going to ask my password. So let me enter my password and press enter, and this time you can see the installation is going on, and it will take a couple of minutes. And once the installation is complete, we can run the final command. So in order to run the final command, we need to open the terminal from the same folder location where your OpenAPI YAML is present. So for the same, let me take you to a folder location where I'm maintaining my YAML document. So this is the folder where I'm maintaining my OpenAPI.yaml. So let me open the terminal inside the same location. For the same, I'm going to right click on the folder and use the option new terminal at folder. So this will open my terminal at the given folder location where my OpenAPI YAML is present. So if I try to run the command ls, it will list all the files present inside that folder. So once you are confident that you have opened your terminal at the same folder location where your YAML file is present, we can run the command which is prism followed by space, and post that we can mention the mock. After that, give a space, and now we need to provide the location where our YAML file is present. Since the YAML file is present in the same folder location, I have to give this // and what is the file name. So the file name is openapi.yml, and post that we need to provide a space followed by -p, which indicates that we want to provide port value as an input to this command. After that, I'm providing the port value. So now I can execute this command. So now you can see the Prism server is started, and it is now listening at the port 8080 with the localhost API which is 127.0.0.1. So these are all the APIs that it recognizes from our OpenAPI specification document, and it is hosted all this. So what I can do is I can take one of these get operation API, and I can try to access this from my browser. So inside my browser I have accessed, and you can see this is the example data that is coming from the OpenAPI specification that we have defined. So very similarly, I can try to access other APIs that we have. So like you can see, we have another API which is going to return the product details. So let me copy this URL, and I'm trying to access the same here. So here you can see it is asking some username and password because this API, whatever we are trying to access, it is secured API because we have enforced the security on this API with the help of security schemes and security keyword. So since these are just mock APIs, we can give any username and any password. So let me click on this login. So now you can see I'm getting a valid response. So now let's try to access other APIs, which is categories, where we are going to return the list of categories supported by the Easy Shop. So here I'm going to provide some random username and password. So let me click on this, remember this password, and click on this login. So here you can see these are all the category details that we have mentioned inside the examples of the OpenAPI specification document. So let me open the same URL inside my Chrome browser so that you can see this JSON structure clearly. So here I came to my Chrome and I'm trying to access this. Let me give some username and password and click on the sign in. So now you can see this is my JSON data, which is organized properly and formatted properly. And this formatting of JSON is happening inside my Chrome browser because I have a plugin inside my Chrome browser with the name JSON View. So feel free to install the same if you want to view your JSON responses like this inside your browser. So now you can see this data is coming from the examples that we have mentioned inside our OpenAPI specification. So for categories, we have provided 2 examples. So let me show you that. So here inside our OpenAPI specification, if you scroll down towards the categories API under the responses, we have defined 2 types of examples. One will return all categories data, and the second one is going to return only the single category data. So we have also given some name to these examples. So by default, it is returning the very first example data that we have here. And if you are not defining these examples, then your mock response will not work, because your Prism mock server does not have any clue what it needs to return. So that's why please make sure you are defining these examples data properly inside your OpenAPI specification. Of course, we have not defined these examples for all the APIs inside this course, but I would recommend you doing that so that your mock APIs will have these examples. And there might be some scenarios where you want to have this example as a mock response, or maybe instead of 200 response, you want to have 500 as a response from your mock APIs. So these kind of scenarios also we can easily handle with the help of Prism mock server. We just have to tell to Prism mock server like which response it has to provide inside the mock response and which example it has to provide. So those details, if we can provide to the Prism server, it is going to respond with the same response that you have requested. So how to do that is with the help of an header inside your request. So in order to provide that header, let's go to the Postman. So now I'm inside the Postman. I'm trying to access this URL, which is categories, and I'm expecting it is supposed to give all the list of categories. So let me try to click on the send button. So now you can see it is throwing a 401 error because I have not entered any authorization details. So for the same, what I can do is I can click on this authorization tab and choose the basic auth, and I can enter some random username and password, and post that I can click on this send button. So now you can see I'm getting the list of categories inside the body, but I want to have the data from the other example that we have defined. So the other example that we have defined is single category data, where we are going to get only one list of category details, which is mobiles. So for the same, we need to take this example name and post that inside the Postman. Go to the headers and give the header name as prefer, like P capital. And once we have given this prefer header name, inside the key we need to mention example is equal to what is the name of your example. So this is the example that I want to get inside my response. So now if I try to send this request, you can see I'm getting only one category details because I'm trying to switch the examples data using this prefer header supported by the Prism mock server. So very similarly, we can also switch the whole responses, like using code is equal to, I'm going to mention the 500. Like inside our responses, if you see here, we have 2 types of responses. One is for 200, the other one is for 500. So there might be a scenario where you want to test 500 response. So that's why I'm mentioning here code is equal to 500. And now if I try to send this request, you can see I'm getting a 500 internal server here. So this way we can also switch the mock responses by using this prefer keyword. So I hope you are getting the power of OpenAPI specification. I'm trying to test all these APIs with the help of browser and Postman, but your consumers, what they can do is they can start writing their client code, and using these mock APIs they can try to test their code end to end, and once the producers APIs are ready, they just have to switch the URL from mock URL to the actual URL, and there should not be surprises because you have used the mock API response which are built based upon the OpenAPI specification provided by your producer. So I hope you like this. Like in future, whenever you have OpenAPI specification document, please don't wait for your producers to complete their development. You can simply mock your APIs with the help of Prism Mock Server by following the steps that we have discussed. Thank you, and I'll catch you in the next lecture. Bye. Like we talked many times inside this course, like one of the primary advantage of building OpenAPI specification for your APIs is we can leverage the automation tools which can help in generating the initial code both on the consumer side and the producer side. So using these automated code generation tools, we can generate the client code or server stubs for many of the popular languages like Java, Python, JavaScript, Scala, Ruby. So within a matter of seconds, we can generate this code. So inside this lecture, I'm going to show you how to generate the server stubs with the help of OpenAPI specification. So server stubs means this is the initial code that you can leverage in order to get started building APIs on the backend server. So for the same, we can go to the Swagger editor tool. So now inside the Swagger editor tool, once you feel that your OpenAPI specification looking good and this is the final version, what you can do is you have an option of generate server here on top of the Swagger editor website. So let's click on that. So like you can see here, these are all the languages and frameworks that are supported by the Swagger in order to generate the initial server stubs code. So there are many languages and many frameworks. We can't explore each one of them. So that's why what we can do is we can randomly download most commonly used frameworks and languages. And once we download, we can verify how that code is looking like. So for the same, what I'm going to do is I'm going to generate the server stubs code for the Node.js. So I have clicked that. The download started, and similarly I'm going to generate the server code based upon the Spring framework, which is a majorly used framework inside the Java ecosystem. So let me click on this. So this also starts download inside my browser. So once the download is completed, we can go to the downloads folder. So this is my download folder location, and I have extracted these zip files that downloaded into folders like Node.js folder and very similarly Spring Server generated folder. Inside these folders, you can find the code that got generated with the help of Swag code generator tools. So in order to explore this code, we can go to the Visual Studio Code. So inside my Visual Studio Code, I'm going to open those folders like by choosing open folder and going into the downloads. First, we can explore the Node.js related code. So like you can see here under this parent folder, we have all the subfolders, and we also have index.js and readme.md. So right click on this readme.md and choose this option open preview, and you should be able to see what are the steps that you can follow in order to leverage the source code that is generated by the Swagger. So here you can see if you want to get started with this project code, which is a node based code, you can simply start the npm start command and open this URL, which is http localhost 8080/docs, where you can see your APIs explained inside and Swagger UI format. But here we are more interested about the code that got generated. So if you go and check index.js, so this is the initial file that will get considered by my Node.js. So inside this, we can see we are saying all our routing controllers are available inside this directory, which is controllers. So if you go inside this controllers, there are 3 JavaScript files which are like categories, orders, and products. So if I open this categories.js, inside this you should be able to see the APIs related to the categories, like one is get categories and the other one is get category details. So these function names are getting derived based upon the operation ID that we have defined inside our OpenAPI specification. And since get categories uses an optional get category ID parameter, it is accepting the same. And even for the get category details, which supports the path param, here also it is accepting the category ID as an input. So now inside these controller classes, you can see we are just invoking the code present inside these category services, which is present under this service folder. So now if I open this category service, so inside these functions like get categories, you should be able to see my code simply returning the examples data that we have defined inside our OpenAPI specification. So which means as of now, you just have a skeleton code which always return example data that you have written, but it's your responsibility to write your actual business logic like querying the database, fetching the data and returning the same as a response. But you can see most of the job is already done, like majority of the code is generated automatically. And in order to write all this code by a developer, it will take at least weeks and weeks of time. So that's a major advantage that we have whenever we start writing OpenAPI specification first, followed by the coding. So at the same time, you can also see under this API folder, we have this OpenAPI.yaml that is leveraged by the Swagger code gen tool in order to generate this code. So this way we can easily get started in the scenarios where OpenAPI specification is already present. And with the help of Swagger code gen tool, we can generate the code and we can make our developers' lives easy so that they can get started and focus on only the business logic, but not with the initial skeleton code. So now we can close all these files and we can open the new folder which is related to the Spring. So for the same, let me go to the downloads and open this Spring Server generated folder here. And here also, if you can right click on this readme.md and you can choose this option open preview. So now whatever I'm going to show you and explain, it will only make sense to you if you're already familiar with Java and Spring Boot. Otherwise, you can simply ignore the discussion that I'm doing around this Spring Server code that is generated by the Swagger code gen. So here you can see these are the details about this application which is generated by the Swagger code gen. You can easily get it. So this is a Spring Boot project. So now if you go and check the source folder under the Java, we have all the packages. First, if you check these model classes like address.java, which we have defined inside the component schema, you should be able to see all the fields that we have defined like address line 1, city, and we also have state, and state has some enum values like California, Texas, Indiana, New York. So each and every details will get captured by the Swag code gen tools and they'll make sure all the details present inside the code that got generated. So very similarly, you can open this API folder and here, if you open any of these class like orders API, you can see this is just an interface where we have various operations defined or methods defined based upon the paths that we have defined inside OpenAPI specification. So if you can see, this is the method which is delete order details, which is going to support path/orders and HTTP method delete. And very similarly, we also have get order details using path param. So all these method names derived from the operation ID that we have defined. So inside this interface, all the methods are available with the supported HTTP methods and API path details. And if you open any of the controller class, like for orders API, this is the controller class. So inside this controller class, it is going to implement the interface which is orders API. And inside the methods that are present inside this controller class, you can see we are just returning some dummy data inside these methods. And this is the place you need to write your business logic, like fetching the data from the database. So with this initial skeleton of your server stubs, your job is going to be super easy. And you can also see here all the programming language standards are being considered while generating this server code. So I hope you are clear like how to generate the server stubs with the help of OpenAPI specifications. My humble request is you can try to generate the server code for the language and the framework where you have some good understanding, and accordingly you can explore all the code that got generated, and in the process you can also feel the power of these automated tools provided by the Swagger. And this is all possible because we have written a valid OpenAPI specification by following the OpenAPI specification standards. So in the next lecture, we can also try to generate the code related to client. Thank you, and I'll catch you in the next lecture. Bye. Now inside this lecture, let's try to generate the client code with the help of OpenAPI specification document. For the same, if you see here inside the Swagger editor, we have an option of generate client. If you click on this generate client, you have the option of various languages, and when you click on them, the client code based upon a particular language is going to get generated, and we can explore few of the languages here. So the language that I'm going to choose is JavaScript, and once the JavaScript is downloaded, we can generate the client code based upon Java as well. So this downloads both JavaScript and Java code. So now I have successfully downloaded the client code based upon the JavaScript and Java programming languages, but feel free to generate the client code for the languages where you are working on day-to-day basis. But for now, inside this lecture, we are going to discuss about JavaScript and Java code that we have generated. So for the same, let me go to the Visual Studio Code. So now I came to my Visual Studio Code. What I can do is first I can extract the downloaded files, and post that I can import those folders into my Visual Studio Code so that we can explore the code that got generated. So this is my downloads folder, and inside this you can see there are two zip files. So let me extract the code present inside them. So now I have successfully extracted the code. So these are my two folders which I want to explore. So now I can go to the Visual Studio Code and try to explore these folders one by one. So here inside my Visual Studio Code, I'm going to choose the option File, Open Folder. So this is my downloads location. So inside this downloads location, first I'm going to open this JavaScript client generated folder. So with this, I have successfully imported the client code based upon the JavaScript language. The very first step that you can do here is you can right click on this readme.md and you can give open preview. And here you can see there is a lot of information for our consumers, like whoever is trying to get started by generating the client code. So these are the installation steps if they are using Node.js. And they have given various flavors of installation steps if they are using Git, browser, Webpack. So all these are the installation steps that they can follow. And to get started, they have also provided what is the sample code or what is the main class inside this JavaScript project that they can refer, and how to consume an API. So they have given some example here. And if you can scroll down, you can see there are some documentations for each and every API endpoints that got generated. And since we have some good amount of schema objects like address, category, laptop, mobile, so all these model classes documentation they can find by clicking on these links. And at last, there is also a documentation details about the authorization that we have inside our OpenAPI specification. So there is a lot of information inside this readme.md. The reason is usually consumers, they are clueless about our APIs. That's why inside the client generated code, you will see a lot of documentation, whereas in the server code that we generated previously, there is very minimum documentation, because we as a producers or providers, we already know about our APIs. So that's why there are not many details present inside the server stubs that we generated. So now we can explore the folders that we have inside this JavaScript project. So you can see inside these docs, there are some MD files. Like if you right click on this and preview, you should be able to see what are all the properties that are available inside my address objects. Like these are my properties, their data types, and what are the valid enum values for states. So each and every details are captured inside this project. And after the docs, we also have source folder. So if you can open this under this model, we have JavaScript files for all our models. Like if you can open this address.js, inside this, you should be able to see all the variables that we have created, like address line 1, city, state, and zip code. So state also have enum values. That's why it is using state enum here, which is present inside the same file. Like under state enum, we have these valid values like California, Texas, Indiana, and New York. So you can find all these model classes under this model package. And we also have index.js, which is the starting file of your project. And the important folder that you need to worry here is API. So inside this API folder or package, you see there are 3 JavaScript files supporting various API tags that we have, like categories, orders, and products. So if I click on any of these JavaScript file, inside this JavaScript file, you should be able to see the code on how to consume the APIs that are supported by my provider. Like if you can scroll down, so under this get category details method, you should be able to consume your APIs that are provided by your producer, or you can also consume your mock APIs that are available with the help of Prism server. So if you scroll down inside this method, under this call API method, you can see already the path details are mentioned, what is the method that it is going to support, and very similarly authentication details also is going to get passed. Like by default it is considered the very first authentication type inside our OpenAPI specification, which is basic auth. If you want, you can change that, and you can consume your producer APIs based upon the other security mechanisms that are supported by your producer. So very similarly, we have orders API, products API. I hope you are getting a sense like how great this code is. Like even if you ask some developer, a seasoned developer, to write this kind of code, they are going to miss out some standards, or they're going to make some mistakes. So in order to write all this skeleton client code, it will take days and days of time, which we can save with these auto-generated tools of Swagger. So now let's try to explore the Java code. So for the same, I'm clicking on this open folder and going to my downloads folder here and choosing this Java client generated folder option. So let me open the same. So here also most of the stuff will be very similar to JavaScript. Like under this Java code which got generated, you have this readme.md and you can preview the same. And here also you have all the installation steps. Like if you are using Maven, this is the command that you need to execute. Like these are the dependencies that you can add inside your pom.xml. And if you are using Gradle, then we also have the installation steps for Gradle and how to get started. So this is my getting started code. Like this is my sample code using which I can start consuming one of the APIs that are exposed by my producers. So just like how we saw previously, here also we have a docs folder where you can see the details about various objects. Like for address, these are the details. And after the docs, we also have source folder. Inside this source folder, we have these folders. Like under the model folder, you can expect all the model related Java classes. Like for address, this is a Java class, and inside this you can see it has fields like address line, city, state, along with the enum values. And at last you should be able to see other fields like zip code and ease office address, everything that we have defined inside our OpenAPI specification. So after this model class, you can also check another important folder or package here, which is API. So if you open this categories API, inside this, you should be able to see the sample code that you can use in order to consume the APIs related to categories. So inside this get categories call method, you can see I'm trying to send an request parameter with the name category ID. And once I have added all these query parameters, if you scroll down, you should be able to see the code where the actual API consuming code is present. So this way inside this Java project, you have everything to get started, including the authentication related information as well. Like all these authentication related Java classes are also generated. So using this skeleton code, you just have to change the code according to your needs and start focusing on your actual business logic. Like using this code, you can consume the APIs, but once you receive that response, what you are going to do with that? So that is your actual business logic. You can straight away focus on that because majority of the client code is readily available, which we have generated with the help of Swagger CodeGen tool. So I hope this is clear to you. Like my humble request is to generate the client code for the language where you have some expertise, and accordingly you can explore the code and you can try to understand what are all the standards that the Swagger CodeGen is following while generating the code, and you can see how beautifully these tools are going to make our lives easy on day-to-day development. Thank you, and I'll catch you in the next lecture. Bye. Now inside this lecture, I'm going to explain about an OpenAPI library which we can use inside the Spring and Java projects. If you're not familiar about Spring Framework and Java language, feel free to skip this lecture. I just wanted to explain about this great library to the Java developers. So if you're not from Java background, please feel free to skip it. So the library that I want to talk here is Spring Doc-OpenAPI. So this is a Java library, and whenever you add this library inside your Spring Boot project or inside your Spring projects as a dependency, this library is going to scan all your APIs, what is the request structure, what is the response structure, and based upon this scanning, it is going to provide you an Swagger UI within inside your application. And using this Swagger UI, which is embedded inside your project itself, you can understand how your APIs is going to look like, and the same URL, if you want, you can give to your consumers. So it is up to you how you want to leverage this Swagger UI, which is available within inside your web application. And apart from Swagger UI, it is also supports various annotations. So using these annotations, you can explain about your OpenAPI within inside your Java code. The same annotations will be processed by this Spring Doc-OpenAPI library, so that your OpenAPI specification doesn't have to be written manually by you. Instead, you can leverage this library which is available for the Java and Spring frameworks. So let's try to understand this in detail. So for the same, first I'm going to generate a new Spring Boot project. So to generate a new Spring Boot project, I came to the website start.spring.io. So here I'm going to provide few details so that I can generate a Spring Boot project which I can use to build some REST APIs. So I'm going to choose Maven project, and the language are Java, and the version whatever is chosen by default. So under the group, I'm going to give the name as com.easyshop, and artifact I will provide something like OpenAPI. So once we define these details, I'll go with packaging as jar and Java version as 17. And coming to the dependencies, I will click on this add dependencies, and I'm going to add the dependencies related to Spring Web so that I can build some REST APIs. And the other dependency that I'm going to add is Spring Boot Dev Tools, so that I don't have to restart every time when I make a change inside my Spring Boot application. So with this, we should be good. Let me click on this generate button that I have here. So this will download the Spring Boot Maven project. So let's check the same inside the downloads folder. So you can see I have a zip file inside my downloads folder. So let me extract the same. So once we extracted the Spring Boot project, we can come to your favorite ID. So in this case, I'm using IntelliJ ID. So here I'm going to import that Maven project into my workspace by going to the file new module from the existing sources, and I'll go to the downloads. And inside this downloads folder, we have a folder with the name OpenAPI, and choose this pom.xml which is present inside this OpenAPI folder and click open. So this will import that Maven project into my workspace. So now what I can do is I can quickly do a build so that my project will get compiled successfully. Once the build is completed, as of now, it is an empty Spring Boot project. What we can do is we can write some REST APIs. For the same, let me try to create few packages inside this web application. So the very first package that I want to create is model package. Under this, I'm going to store all my model classes. And very similarly, I'm going to create one controller package. And under this controller package, I can write or define all my REST APIs with the help of Spring Boot. Now inside these controller and model packages, I have created some Java classes offline. The same we can validate quickly. So under this model package, we have 4 model classes like address, category, order, and product. So these are just a simple POJO classes with some variables and getters and setters. And very similarly, if you go and check under controller, we have various controllers like category controller, order controller, and product controller. So these are the simple REST controllers. Like you can see inside each controller, we have various APIs. Like under category controller, there are 2 APIs which we build with the help of REST controller, get mapping. And very similarly, if you go to the orders controller, there are some post mapping, get mapping, put mapping, delete mapping. So these are our simple plain Java methods where I'm just trying to return some dummy values. And very similarly, we also have APIs under the product controller. So now think like a scenario where you have everything inside your web application, like all the REST APIs are working fine, but the only problem that you are facing is you don't have an OpenAPI specification document or details for your APIs. So obviously here the lengthy process is you going to the Swagger editor tool and writing the OpenAPI specification based upon your APIs, but that is going to take some time. But to get started quickly around this kind of scenarios, you can use the library that we are discussing previously. So the library is Spring Doc OpenAPI. Just try to Google search for this library and there'll be a website with the name springdoc.org. And inside this website, you can learn everything about this library, how you can use this inside your Spring projects. So to get started, what you have to do is you need to add this as a dependency to your Spring Boot project. So for the same, I need to go to my pom.xml, and inside my pom.xml, I'm going to add this as a dependency. So once we add this, let me load the Maven changes and the Maven libraries. So this will download the Spring Doc library into my web application. So now I can do a build here. Once the build is completed, I can start this web application by going to the main class inside my Spring Boot application. So please identify the main class by looking at this annotation, which is Spring Boot application. I'm trying to start this web application. So this will start our web application at the default port, which is 8080. So once it is started, you can go to the browser, and inside your browser, you can try to access the path which is localhost 8080, which is your base path of your project. And after that, please try to access this path which is swagger-ui.html. So if you press enter, you can see here, this is all the Swagger UI for all your APIs. So you can see without we doing anything, we have a Swagger UI embedded inside our web application, and at the same time you have an UI using which you can pass this information to your consumers, and you can also click on this hyperlink that you have, which will open your OpenAPI specification YAML document. So this also you can provide to your consumers. So this way we can leverage this library, which is Spring Doc OpenAPI, to get started quickly whenever you have REST services already developed with the help of Spring Boot project. And you can see this is all minimum information. There is some good amount of information is missing here inside our OpenAPI specification, like contact details are missing, info object is missing. So if you want to further improvise this OpenAPI specification document, you can leverage the annotations that are available inside this library, and you can define them inside your Spring Boot project, and post that your OpenAPI specification can automatically detect those annotations present inside your application, and the same can be displayed inside your OpenAPI specification. So let's try to quickly use few of the annotations available inside this library inside our Spring Boot application. So what we can do here is inside our Spring Boot application, we can open our main class, which is OpenAPI application. So inside our main class, we can create a bean of type OpenAPI. So like you can see here, I have created a new bean. So let's try to understand what is there present inside this bean. So the return type of this method should be OpenAPI, which indicates we are trying to create a bean of type OpenAPI. So this OpenAPI class is available inside the library that we have added inside the pom.xml, which is springdoc-openapi-ui. So inside the same library only, we have a package that starts with io.swagger.v3.oas. Under this models package, you can identify all these classes like OpenAPI, contact, info, license. So now here you can see, you can think like this OpenAPI object is a kind of root object inside your OpenAPI specification. That's why I'm just trying to create a new object, and inside this object you can invoke the method info, and using the info you can pass the info object like what is the title, what is the description, what is the version, contact details. Under the contact, what is the name, email, URL, and similarly license. Under the license object, what is the license name, what is the URL, and external docs. And very similarly, we can also add the tags for our OpenAPI specification document. So I have created only one tag for now, which is category. So the same tags information I'm trying to add to the OpenAPI root object. So now, since we have added these details inside our Spring Boot application, it is going to auto detect all these details. So now I'm doing a build. So let that build complete and restart completes. If I try to refresh this page now, you can see all the information that we have defined inside our Spring Boot application, like contact details, license details, tax information, everything is coming here. And this is like in the scenario where you want to define some root elements inside your OpenAPI specification, like the info object, license object, or the contact object. But if you have a scenario where you want to describe your API with the help of the annotations present inside this library, we also have certain annotations. So let's try to explore the same. So what I'm going to do here is I'm going to add more annotations to these APIs present inside this category control. So the very first information that I want to add here is we can add that tag annotation, which is @tag. Using this tag annotation, we can group all the APIs like how we group inside our OpenAPI specification. So very similarly, we can group these two APIs under the tag category. So if I try to do the build now, and once the build is completed, the application will get restarted. So now you can see after refreshing the page under the category, we have these two APIs listed. So that's how using the tag annotation, we can define the tag details inside our Java code itself. And after the tag, we also have @operation annotation. Using @operation annotation, we can provide some summary details about our operation. Like for this API, the summary is get category details. I can also do the same for the other API. Like here, I can just mention get category details using path param. So after the operation annotation, we can also use certain annotations to describe the response structure of our API. So for the same, you can see I'm using API responses annotation. So inside this API response annotation, we can describe any number of API responses with the help of @API response annotation. And once we define this API response annotation, inside this you can see we need to mention what is the response code, what is the description, what is the content type, and inside this what is the schema that you are going to return whenever someone get a 200 response. And similarly for 400, 404, we can define the response structure. So this way we have annotations inside this library which you can use to describe your OpenAPI specification from your Java code itself. So feel free to explore all the annotations that are available inside this library from the official website so that you can leverage them. And whenever you use these annotations inside your Java code, you can generate the OpenAPI specification very easily like we have discussed. So now let me save all these changes and do a build. Once the build is completed, we can go to the browser and try to refresh this. So here I'm trying to refresh. So if I go to any of these category APIs, so you can see under the responses now I have 200, 400, 404. So this way everything is possible with this library inside your Spring Boot applications. If you are using Spring Boot inside your web applications to build REST APIs, my strong recommendation is to use this library, which is spring.-openapi-ui. So this will also provide you an embedded Swagger UI inside your web application, and the same URL you can give to your QA team whenever they want to understand what is the request that they want to send, how the response structure will be looking like. So this can be a good starting point for your testing members so that you can save yourself from many questions that are going to come from the testing team. So I hope this is clear to you, and I'm assuming you are going to use this library inside your Spring Boot web applications. Thank you, and I'll see you in the next lecture. Bye. This is a final lecture inside this course, and we are not talking anything about OpenAPI specification. Then you may ask what we are going to talk inside this lecture. So inside this lecture, I just wanted to say a big thank you for giving an opportunity to teach you about OpenAPI specification. You have been a great learner and listener throughout this course, and we together had this beautiful journey of OpenAPI specification. But from now onwards, we have to get separated in this journey, and I hope you will continue this journey of OpenAPI specification, and you will take all this knowledge into your real-time projects and in educating others inside your projects in terms of OpenAPI specification and Swagger tools. Like I promised at the starting of this course, I have provided all the details about OpenAPI specification, and now you can strongly assume you are a master of OpenAPI specification without any doubt. So before you closing this course, I have two requests. The very first one is please take a minute and provide a review to this course about what you feel, what is your feedback, so that this course can reach to multiple other students like you who want to learn about OpenAPI specification. And the second request that I have is inside the next lecture, you can find the list of other courses from me. So please enroll the same if you are interested in these courses. So with this, I just wanted to say a very, very big thank you one more time. And I'm just hoping you to see you again in another course. And here I'm logging off from this course with a small pride that I'm able to help you in the journey of OpenAPI specification. Thank you and goodbye.